February 1943. The chill winds of the North African desert carried the sound of steel over sand as the captured American M4 Sherman rolled to a stop near Sidi Bouzid, its olive-drab armor glinting beneath the hot Tunisian sun. The white star of the United States still lingered faintly beneath the freshly painted black cross of the Wehrmacht, a silent symbol of ownership that told a far more complex story. Around this strange new prize gathered the officers of Heavy Panzer Battalion 501, notebooks already in hand, eyes tracing every contour of the machine that had defied them in battle. They called it War Daddy 2, its name still boldly painted across the hull, serial number 3067641, born from the forges of Lima Locomotive Works and once belonging to Company G, 1st Armored Regiment, 1st Armored Division. To the Germans, this tank was more than a trophy. It was a question that threatened their confidence in everything they believed about armored warfare. As they drove it 350 kilometers across the brutal landscape to the port of Sfax, 4.5 days of rock, heat, and dust, their astonishment grew. The engine never overheated. The transmission never faltered. The final drive sang with steady, unwavering rhythm. German crews, accustomed to halting every few hours to wrestle with broken components and overheated engines, could only stare in disbelief as this foreign machine rolled forward, indifferent to the terrain that crippled their own panzers. At Sfax, War Daddy 2 was hoisted aboard a freighter bound for Germany under strict orders from the Army Weapons Office. The vehicle must arrive intact, for what it represented could reshape the German understanding of industrial warfare. When spring came to Brandenburg, the ship's cargo finally rolled onto German soil at the Kummersdorf Proving Ground, 25 kilometers south of Berlin, the heart of the Reich's technological testing empire. The Sherman bore its new identity now, Zugfahrzeug 259, license plate WH058941, its armor stenciled with chalk marks and numbers by precise German hands. Here, under the cold eyes of the Reich's best engineers, the American tank would be dissected, measured, and tested to its limits. Kummersdorf was a cathedral of machinery and mathematics, a place where every screw and weld was studied like scripture. When they opened the Sherman, they found something both shocking and humbling. The transmission caught their attention first. While German tanks relied on straight-cut gears, demanding impossible tolerances and endless maintenance, the Americans had used herringbone gears, smooth, strong, self-centering, spreading the stress evenly across their teeth. It was a design Germans had dismissed as too difficult for mass production, yet the Americans built thousands of them with ease. The trials began. They drove War Daddy 2 across mud and sand, up slopes, through obstacle fields. They recorded fuel use, monitored oil pressure and temperature, and disassembled every system after testing to inspect wear patterns. What they discovered defied everything they believed about tank design. The Sherman performed adequately in combat metrics, but superbly in endurance. It didn't need constant servicing. It didn't punish its drivers for small mistakes. It simply worked. Its 5-speed synchronized gearbox allowed even untrained men to drive it as easily as a civilian truck. Its Continental R975 radial engine shrugged off extremes of heat and cold. Its cooling system and air filters, untroubled by desert sand that had ruined so many German engines. Where Germans pursued precision and complexity, the Americans had pursued practicality and resilience, and it was winning. By June 1943, the Reich's Minister for Armaments, Albert Speer, arrived to witness the results for himself at Hillesleben artillery range. A demonstration awaited. The Sherman would climb side by side with Germany's latest marvels, the Panther Ausf D and the mighty Ferdinand tank destroyer. Before a crowd of officers and industrial magnates, War Daddy 2 began its ascent. Its gears shifted effortlessly. Its radial engine roared but never faltered. The driver barely broke a sweat. Then the Panther followed, stronger, heavier, boasting a 700 horsepower Maybach HL 230. It climbed, but not easily. The Ferdinand began its turn and stalled midway, dead on the slope before the eyes of Germany's most powerful men. The recovery crews rushed in embarrassment. Speer's expression hardened. He would later recall, during his inspection tours in Italy, that reports of the Sherman's cross-country mobility had been overwhelmingly favorable. Tanks climbing mountains that German experts had once declared impassable. He wrote, "A very powerful motor in proportion to its weight. Its cross-country mobility on level ground is definitely superior." By that end of the month, even German newspapers, wrapped in propaganda, were forced to acknowledge the uncomfortable truth. Das Reich described the Sherman as one of the special accomplishments of North American laboratories, calling it a praiseworthy product of the North American steel industry. They noted the mass production precision, the innovation of the gyro-stabilized gun, the first of its kind in the world. Between the lines, the engineers knew what this meant. American tanks weren't merely functional, they were industrial miracles. Throughout the summer and autumn of 1943, the tests continued. The Sherman's operational range exceeded 2,000 kilometers before requiring serious maintenance, 4 times the range of an early Panther. Its transmission efficiency outperformed every German vehicle tested. Its final drives, built with the same herringbone precision, refused to fail even under punishing stress. Meanwhile, Panthers and Tigers limped through the field, their straight-cut final drives shattering within 100 kilometers. At last, the engineers compiled their reports, internal documents meant for senior Wehrmacht officers only. What they contained was devastating. A quiet admission that the Americans had surpassed Germany not through superior intellect, but through superior execution. The Sherman reflected an industrial maturity born from decades of automobile manufacturing experience, something Germany had never possessed. Before the war, cars in America had been the tools of the working man. In Germany, they were luxuries for the elite. That difference echoed through every bolt and bearing. The United States built tanks that ordinary mechanics could repair with basic tools. Germany built tanks that required artisans and specialists, and fell silent when they weren't available. Reports poured in from the field, Panthers breaking down after short marches, third gears snapping, transmissions destroyed by simple turns in reverse. Drivers were warned not to shift too often, not to turn too sharply, not to back up while turning. Warnings that made the Panther as fragile as glass in the hands of its crews. The Sherman, by contrast, could be driven hard, repaired first, and returned to battle without waiting for experts. American factories, Ford, GM, Chrysler, turned out transmissions, engines, and drivetrains that fit together perfectly no matter where they were made. Caterpillar tractor built parts to the same specs as Buick and Ford, and they could all be swapped without adjustment. In Germany, each manufacturer's Panther differed subtly from the next, their parts often incompatible. Yet even as captured Shermans arrived from Italy, from the Eastern Front, from burned-out battlefields, the engineers at Kummersdorf found the same thing again and again: consistency, durability, predictability. Even the British Firefly variant, with its massive 17-pounder gun, impressed them. Its large turret ring, built into the original design, allowed the heavier weapon with minimal alteration, a level of foresight the Panther never had. German tanks could not be upgraded so easily. Their designs were masterpieces that could not evolve. Through 1943 and into 1944, the numbers spoke with brutal honesty. Panther readiness hovered below 40% for most of 1943, dropping as low as 20% in some battalions. At Kursk, mechanical failures destroyed more Panthers than Soviet guns. Even by mid-1944, after countless fixes, their success rates barely approached what the Sherman had achieved straight out of the factory. Engine lifespans for Panthers reached 1,000 kilometers on a good day. Sherman diesels exceeded 3,000. In desperation, German units began using captured Shermans in combat without modification, forming ad hoc companies of American-made tanks. They didn't need to change a thing. These machines worked perfectly well for the Reich, and irony not lost on the soldiers who drove them. In January 1945, the 10th SS Panzer Division captured a dozen M4A3 Shermans during Operation Nordwind. They formed an entire company, the 13th of the 10th SS Panzer Regiment, fighting the final months of the war in stolen American steel. By then, every German commander understood what the engineers at Kummersdorf had learned in 1943. Firepower mattered less than dependability. A Sherman that arrived ready to fight was worth more than a Panther stranded 20 kilometers behind the lines. Through 1944, as the Reich crumbled, engineers tested every Sherman variant they could find. The M4A1 with its R975 radial engine, the M4A2 with twin GM diesels, the M4A3 with its 4 GAA V8. All of them performed with astonishing consistency. Even the M4A2's diesel engine impressed, consuming less fuel, something Germany desperately needed as its supplies dwindled. American industry had mastered flexibility, producing gasoline and diesel models side by side without missing a beat. The Reich had tried and failed to do the same. By March 1944, Guderian's reports proclaimed acceptable Panther reliability, 700 to 1,000 kilometers of engine life, and somewhat fewer final drive failures. What the German army celebrated as a triumph merely matched the standard American tanks had met from their first day of service in 1942. But as Allied bombers darkened the skies, even that fragile progress began to collapse. In April 1944, RAF Bomber Command sent 322 aircraft to strike Friedrichshafen, the heart of Germany's armored industry. The Maybach engine plant and adjacent ZF gearbox factory were destroyed in one night. Tank production halted for 6 months. When the factories reopened, they ran on slave labor, starved men and women who sabotaged the machines they built, slipping cigarette filters into oil lines, misaligning gaskets, damaging bearings. By then, the Sherman factories in America were running at full strength, safe, clean, efficient, powered by skilled workers, earning fair wages, untouched by war. And so, beneath the soot-stained rafters of Kummersdorf, surrounded by the ghosts of their own ambitions, the German engineers finally faced a truth they could no longer deny. The contest between the Sherman and the Panther was never just about tanks. It was about civilizations. One built on industrial freedom, the other on rigid perfectionism. One valued simplicity and mass production, the other worshipped precision until it strangled itself. In the end, it wasn't the thickest armor or the biggest gun that decided the war. It was the machine that simply kept moving. And that machine was called War Daddy 2.
Under the dim lights of a war-torn continent, the clash between theory and practicality unfolded not only on the battlefield, but deep within the foundries and workshops where machines of destruction were born. The German Panthers and Tigers, with their gleaming steel armor and monstrous guns, looked invincible on paper, monuments to precision and power. Yet beneath their intimidating exteriors lay fragile hearts, engines straining under 45 tons of burden, transmissions that cracked under stress, and final drives that surrendered long before the enemy ever fired a shot. The Panther's high-velocity 75mm gun and the Tiger's commanding presence became symbols of a fatal imbalance, brilliance chained by complexity. They demanded constant attention, endless maintenance, and mechanics trained more like surgeons than soldiers. Meanwhile, across the ocean, American engineers, men who had spent decades perfecting assembly lines and building reliable trucks and cars, applied their craft to war. They didn't chase perfection, they pursued function. The M4 Sherman, with its unpretentious design, became a mechanical miracle of consistency. Built for mass production, repairable by ordinary hands, its parts interchangeable and its systems forgiving, it embodied the quiet genius of practicality. Where German tanks faltered after every long march, the Sherman rolled on, steady, unyielding, ready for the next fight. Its powertrain, borrowed from proven automotive models, rarely failed. Its electrical systems, including a backup generator for turret rotation, seemed like luxury to German designers. But in the chaos of battle, when the main engine died, that luxury often meant survival. By 1944, the difference was undeniable. Reports from the front poured in. Panthers restricted from long road marches to prevent mechanical suicide. Recovery vehicles breaking down while rescuing their broken kin. Tank battalions losing more machines to failure than to enemy fire. Some units admitted grimly that 70% of their tank losses came not from Allied shells, but from their own engineering. And while Germany struggled to keep its sophisticated beasts alive, American factories roared, producing nearly 50,000 Shermans, more tanks than all of Germany's types combined. From Normandy to Burma, from Soviet steppes to Chinese jungles, these reliable workhorses proved that endurance outshines elegance. Even German crews who captured Shermans spoke of them with admiration, calling them marvels of automotive simplicity. To them, the Chrysler A57's 5 engines seemed easier to service than their own Maybachs, which demanded constant calibration. The Ford GAA V8 with its steady pulse felt immortal compared to the finicky German motors that required endless adjustment. Even the twin diesel engines rejected by the U.S. Army as less reliable outperformed any diesel Germany had ever built. The Sherman's secret lay in its hidden strength, an abundance of design margin. Its transmissions, drives, and axles could handle far more power than originally required, easily adapted for heavier armor or stronger engines without redesign. German engineers scoffed at this as wasteful, but American designers knew durability wasn't waste, it was foresight. When the invasion of Normandy began, this foresight decided the war's rhythm. German panzers could strike hard, but only once before collapsing into mechanical exhaustion. American tank battalions could fight, refuel, repair, and fight again. Where Germans counted kilometers before breakdowns, Americans counted victories. Captured Shermans served in German units during the Ardennes offensive, chosen precisely because they could be trusted to run. But even then, most German crews could find only one in working order. It never reached battle, trapped in traffic, while its Panther counterparts wheezed and died. In January 1945, the truth could no longer be denied.
At a meeting of the Panzer Commission, grim reports listed catastrophic failures. Hundreds of defective final drives in Panthers, Panzer IVs, Tigers, and Hetzers. Generals admitted that entire units were abandoning tanks for fear they'd stall mid-battle. The psychological toll was devastating. Soldiers lost faith not just in machines, but in the promise of their industry. Even as Soviet guns thundered toward Berlin, desperate engineers at Kummersdorf packed up their research, test logs, blueprints, and the wrecked remains of captured Shermans, hoping that somewhere, somehow, the lessons might survive. On the front, those same Shermans fought alongside German tanks in the last days, a surreal alliance of necessity. The Shermans kept running until fuel ran out or shells pierced their armor. The German tanks beside them, though mighty in theory,
fell silent from broken gears and seized engines. That was the real lesson of Kummersdorf, that greatness measured on a blueprint meant nothing if the machine couldn't carry its crew to battle. The American philosophy of build it simple, build it strong, build it to last had triumphed over Germany's obsession with over-engineering. When the war ended and the smoke cleared, that truth echoed in every ruined factory and burned out Panther husk. The post-war German designers took it to heart. As the new Bundeswehr arose and engineers sketched the first Leopard tanks, they abandoned the ghosts of the past. No more chasing impossible perfection. They studied the Shermans, the lessons of Detroit's factories, and built the Leopard 1 with simplicity, strength, and serviceability in mind. The Leopard became one of the Cold War's greatest tanks, a living monument to lessons learned in defeat. War Daddy 2, the Sherman, whose name remained scrawled on its hull at Kummersdorf, became more than a test subject. It became a teacher, proof that practicality wins wars, proof that a reliable engine can decide the fate of empires. Every mile it traveled without failure whispered the same message. Germany's engineers had built marvels that couldn't endure, while America's had built endurance itself. Every broken Panther gearbox, every overheated Tiger engine, every abandoned hulk rusting in the mud of the Eastern Front testified to the same truth. Wars are not won by brilliance alone, but by the machines that keep moving when brilliance breaks. The Sherman may never have been the most powerful tank, nor the most feared, but it was the one that always arrived. It fought, it survived, it returned to fight again. And in that endurance it carried an empire's strength. Even now, decades later, engineers studying those wartime relics can trace the evolution of wisdom written in grease and steel, from the perfection that failed to the reliability that prevailed. The war for the world's future wasn't just fought in trenches or skies. It was fought in the quiet hum of engines, in the unseen moments when one tank stalled and another rolled forward. And in that eternal contest between complexity and consistency, between dreams and discipline, the Sherman tank and the philosophy that built it prove that in war, as in life, the greatest power is not perfection, but persistence.
Long after the echoes of artillery had faded, and Europe's battlefields turned to farmland once more, the story of War Daddy 2 and the quiet revolution it represented didn't end. It lingered, in blueprints scattered across drafting tables, in dusty archives where engineers pored over brittle documents marked Geheim Kommando Sache, and in the whispered recollections of old mechanics who still remembered the smell of oil and hot metal under a shattered Reich. When the war ended, the victors gathered not just trophies, but knowledge. The Americans took home trainloads of captured equipment, notes, and technical data from Kummersdorf and Peenemünde alike.
dissecting the German machines with the same relentless curiosity that had once driven the Germans to study the Sherman. In laboratories from Aberdeen to Detroit, the lessons were catalogued and absorbed. Simplicity beats sophistication when the world is burning. The engineers who had built the Sherman moved on to a new era, one shaped by jet engines, atomic power, and a Cold War that promised annihilation rather than conquest. But they carried those wartime lessons like sacred scripture. When they designed the M48 Patton, the M60, and later the M1 Abrams, they began not with the question of firepower, but with one truth: will it run tomorrow? Because the best tank they now knew wasn't the one that could destroy everything in front of it. It was the one that could still move when everything else stopped. Across the Iron Curtain, former German engineers, now working under new flags, watched this evolution with a strange mix of pride and regret. They saw the same principles reborn in the Leopard 1, that sleek and agile successor of their failed dreams. Its lines were clean, its systems intuitive, its powertrain forgiving. It was not the monstrous Tiger reborn. It was the Sherman's grandson, shaped by the humility of defeat. The irony was almost poetic. The very army that once worshipped over-engineering now found salvation in simplicity. Meanwhile, in the United States, the spirit of wartime industry transformed into something far greater than war itself. The same factories that once stamped out tank hulls by the thousands began producing cars, tractors, and machines that fed the post-war world. The assembly line precision that had rolled out Shermans in an endless tide of steel now rolled out the prosperity of an entire generation. The victory of reliability had crossed from the battlefield into daily life. But memory is a fragile thing. As the decades passed, the roar of tank engines gave way to the hum of computers. The Shermans rusted in museums, their paint peeling, their stories fading beneath the fingerprints of curious children who had never known war. Yet deep in archives and collectors' garages, a few old engineers still told the tale. They remembered the day a captured American tank rolled into Kummersdorf and humiliated the Reich's finest minds, not through speed or strength or brilliance, but simply by not breaking down. They spoke of that day with quiet reverence, because it marked something rare in history, the moment pride surrendered to practicality.
One such man, years later, would stand before a dusty Sherman in a West German museum, his hair white, his hands trembling from age and memory. He had once written reports for the Panzerkommission, detailing the failures of the Tiger's final drives. Now, staring at the squat, boxy shape of War Daddy 2, he could almost hear the old engine turning over again. "You were never beautiful," he whispered in German, his voice cracking. "But you never failed us, not once." And in that moment, the machine seemed to stand as a quiet monument, not to war, but to endurance itself.
The engineers of the post-war world would build faster, stronger, and smarter machines. They would chase new frontiers, space, speed, digital perfection. Yet hidden within every modern tank, aircraft, and engine lay a trace of the same principle that War Daddy 2 had proven in fire and mud. Reliability is the soul of victory. The Cold War's balance of power rested not on flashy prototypes or theoretical performance, but on the unglamorous discipline of machines that worked every single day without complaint. As the decades turned into centuries, the old battle between complexity and simplicity continued. New generations of designers faced the same temptations to overreach, to perfect, to make something that should work better than anything before. But history, patient and watchful, whispered reminders from the rusted hulks of the past. Remember Kummersdorf. Remember the tiger that couldn't reach the fight. Remember the Sherman that did. And so, the legacy of War Daddy 2 lived on, not in the thunder of cannons, but in the quiet heartbeat of every dependable machine mankind ever built after. It lived in the hum of engines that never quit, in the code of systems that kept running even when the world faltered. It lived in the hands of every engineer who learned that perfection is hollow without reliability. The Sherman had no glory song, no heroic silhouette, but it had truth written into every bolt and gear. In war, as in life, the most powerful weapon is the one that endures. And that is where the story of War Daddy 2 rests. Not in the pages of forgotten reports or the dust of a museum floor, but in every heartbeat that still quickens when history comes alive again. You see, the past isn't gone. It's just waiting for someone to listen. Maybe that's you. Maybe that's all of us, trying to understand how men, machines, and moments shaped the world we live in. If you've made it this far, thank you for walking through time with me, through mud and metal, through mistakes and miracles. History isn't just about battles. It's about lessons, about people who learned, failed, rebuilt, and kept going. So if stories like this, stories that breathe life back into forgotten corners of the past, speak to you, then don't let this be the last one. Hit that subscribe button, leave a like, and share this tale with someone who still believes that history is worth remembering. Because here, on this channel, we don't just tell stories, we bring them back to life. Until next time, stay curious, and I'll see you in the next story.